In space, time passes strangely. Day becomes night, and night day, as if we are passing through tunnels. Captain James Lovell.
The sun seems to come up quite steadily as it does. We can see the colors along the horizon from quickly in a deep blue to a light blue to perhaps a pink as the rays bend slightly around the Earth. Of course, it's all black right above it. And suddenly the sun just pokes itself above the Earth's horizon, and then it's a brilliant white. And as a matter of fact, you don't want to be looking just prior to sunrise at that area. You want to be looking away from it a little bit because the sun is so brilliant.
The steep mountains of Iran lie beneath us. Hidden behind the mountain barrier are the ruins of one of the great cities of the ancient world, Persepolis, capital of the Persian Empire, destroyed 2,300 years ago. Colonel Borman.
In space, of course, there are no winds. You don't have the drift problem you have in airplanes. So really, you can put your orbital marks on this map, and just by time, you can mark off the time and say, well, I should be over Calcutta. And you look down, and there's Calcutta.
Not only Calcutta, but the whole subcontinent of India lies 600 miles below. 1 million square miles from her tropical south to the northern mountains facing Russia and China. Colonel Aldrin.
If you look close, you can see some of these very uniform lines that convinces you that man's down there, and he's made his mark on the planet that is visible from 160, 180 miles.
Now the frozen roof of the world, the Himalayas, tallest mountains on Earth, which for centuries have challenged man's endurance, yet insignificant from space. 9 of the world's 12 highest peaks are in this one view. K2, or Mount Godwin-Austen, over 28,000 feet above sea level, lies below. The dark patch in the center is Mount Everest in perpetual winter, 29,000 feet tall, highest mountain on Earth. We're only about 1/2 from our starting in Florida as the spaceman flies. We are crossing from India into Tibet, on our way toward the heartland of central China. We will cross China from west to east, following her meandering rivers just as men have done since recorded time. We trace the Yangtze, longest river in Asia, from her source past Chongqing, Wuhan, and Nanking. Shanghai in the Yangtze Delta at the upper left. We move freely along the China coast over the ports of Fujian, Hong Kong, and along the Tonkin Gulf toward North Vietnam. Below, dotted by clouds, North Vietnam. Before 1957, neither man nor anything man-made was in space. Since then, the United States and the Soviet Union have launched some 3,000 objects, most of them unmanned and American-made. They have traveled out as far as Earth, past Venus. Some have been in the atmosphere. Some will continue traveling for 1,000 years. They've looked out and they have looked back, sending to us new knowledge of the Earth's magnetic shield and gravity, the sun's radiation, the composition of the moon, Mars, and Venus. to conceive such complex tasks, to design and build their hardware, men had to devise entirely new approaches to the very question of problem solving, with incalculable values to other problems here on Earth. Many innovations have already come from space. For industry, new metal alloys and long-life power sources. For medicine, new means to monitor the human condition. 2,500 technical developments. And we have just begun as we approach the moon. The moon seemed the only way it could be seen a short decade ago. Yet by the mid-1960s, we achieved our first close-up view as the unmanned Ranger spacecraft televised its pictures back to Earth before crashing into the moon's surface. Next, a Soviet and then an American vehicle landed softly on the moon and scanned the strange scene. Our surveyor Communication satellites have been carrying telephone and television signals between continents since 1965, and soon some 50 nations will be linked by them. Perhaps the family of spacecraft immediately affecting the greatest number of Americans are the weather satellites. Our various meteorological vehicles keep daily watch on the world's cloud cover, increasing the accuracy of weather forecasting. It is estimated that only 10% more accuracy in predicting weather could save $2.5 billion annually for farmers and industry in the United States. Weather satellites have proven their worth through advance warnings of storms, whose habits are then studied for the future. One classic case was in the great hurricane of September 1967. Here we see a yet unnamed tropical disturbance when a weather satellite first located it far out in the central Atlantic on September 1st. For the next 6 days, the storm is tracked by the satellite as she heads westward. Then by September 8th, the disturbance has become a full-fledged hurricane. Warnings are flashed throughout the Caribbean and beyond about the hurricane, now named Beulah. On September 10th, Beulah brushes past Puerto Rico and the next day lashes the Dominican Republic. The weather satellite continues dogging the hurricane's heels. Between the 13th and the 14th, south of Jamaica, Beulah picks up speed and races toward the mainland. A top priority emergency warning comes some 20 hours before Beulah strikes the Texas coast near Brownsville. After a 24-hour rampage, the storm moves on, leaving $1 billion in damage and some 300,000 people homeless. Yet the advance warnings have cut the toll in human life to 41, thanks to the view from space. Other space views are helping provide us with security. ABC News science editor, Jules Bergman.
Both Russia and the United States have large and very active space reconnaissance programs with satellites that use both television and film cameras. We launch our recon spacecraft into polar orbits so that Red China and Russia are visible beneath them in daylight hours every day. What they have discovered since we started launching them regularly in 1963 has saved America untold billions of dollars in unneeded armaments and possibly prevented a war based on miscalculation of an enemy's strength. The spy satellites are mostly called SAMOs, for Space and Missile Observation Satellites. They first uncovered Red China's growing nuclear strength. The birth of Russia's new nuclear-powered, missile-equipped submarines was also closely watched. One fantastic picture taken last year, none have ever been released, by the way, spotted more Soviet nuclear submarines being built in one yard on the Baltic than were being built in all the American shipyards. The alarm bell rang. Russia had a sub that was faster and deeper diving than many of ours. It was found out in time, and faster, deeper diving U.S. subs have now been given the go-ahead. How is this done? As our recon satellites orbit the Earth, quick-look shots are recorded on videotape by TV cameras, then broadcast to ground stations in California, Alaska, and elsewhere as the satellite passes overhead. Higher quality pictures are made with film and returned periodically to Earth in camera capsules, which are retro-rocketed out of orbit. This film sequence shows a blazing capsule ejected from a recon satellite. Although these motion pictures show recovery from a satellite other than Samos, the technique is identical. Special aircraft flying out of Hawaii and other Pacific bases search out the camera capsule, which has now released a parachute to slow its descent. Special equipment is put into place behind the plane, ready to snag the capsule. And the recovery is made. What can be seen? The following examples approximate real recon pictures shot from aircraft and spacecraft. Against the sun glitter on the ocean, here can be seen ships' wakes, viewed from an airplane in this case. The ships are long since gone, but where these two wakes come together, a submarine and its tender had rendezvoused. And by the use of infrared and other photographic methods, we can determine their speed and whether they are nuclear powered. There are fewer places to hide each day. This is Fort Worth and Dallas, a wide stretch of Texas filmed by Apollo 6. Carswell Air Force Base with Strategic Air Command B-52s on the runways is clearly visible. Even small planes can be counted. The methods used are highly classified. This is a shot from a not very advanced recon camera being tested to see how well it would pick up the enemy in Vietnam. Now the close-up of the same shot. Clearly picking out a parked truck, its identification, and its driver. Even if there were a forest canopy obscuring the scene, new sensors and cameras could have found it. In a little-noticed speech last year, President Johnson paid tribute to space spying. More than enough billions have been saved, he declared, to pay for the entire military and civilian space programs.
And now, on the last leg of our voyage across the Pacific, we see yet another view from space. Colonel Buzz Aldrin leaves the capsule on EVA, extravehicular activity, in training for flights to the moon. We see what he saw and hear how he felt.
You would think that now as you open the hatch to exit the spacecraft that you might want to think of which way is up and down relative to the Earth. But that's not true at all, because all of your attachments and your handholds and everything that you're interested in is right there in that spacecraft, and you really don't care where the Earth is, except perhaps if you're taking some pictures. There's absolutely no concern at all about any falling tendency toward the Earth. Well, I guess fantastic is the best way to describe it. Looking through the window from inside tends to frame your view, but when your head is out in space, it just seems as though it's everywhere, and you're there right with it.
The coral atolls of Micronesia, heading toward Hawaii.
This the Hawaiian island chain. You can barely see the light atolls down here.
Buzz said he saw a few grass skirts here, but I don't believe it.
Well, you see Diamond Head. Can't you see it?
Our EVA ends. We streak toward the United States.
See smoke come offshore down here.
Well, there obviously can't be any intelligent life down
No. Who'd be dumping that sort of stuff in the atmosphere?
The clouds have broken, and there's Los Angeles under its man-made cloud of smog. We head inland over the Salton Sea toward Arizona, New Mexico, and Texas. We are completing our first orbit. There's the mouth of the Mississippi River. Ahead, the Florida Peninsula, where we began. We are to pass over Cape Kennedy again, and then out to sea. Our return to Earth begins. Captain Lovell.
The first thing that happens is really nothing. You're still up there, coming down, and then suddenly the heat shield starts hitting the upper atmosphere, and the sky takes on sort of a pinkish color. The gases are starting to ionize, and then you start feeling the effects of gravity. About the time you're pulling about 3 Gs, the ablative material, of course, is melting away, and it's coming off in big chunks, and the ionization has turned green. It's a green gas now, and you can see the flames out in front of you as you come on through. This holds about the same all the way down until you go subsonic, and suddenly there's a big rush of sound because you can hear all the noise now coming through. And from then on, it's a very pleasant ride.
At about 10,000 feet, the parachutes open, slowing our return through the atmosphere. For a very brief moment in time, man has touched the periphery of the universe. He has seen his planet as it has never been seen before. The view from space is staggering. But 2 questions remain. Was it worth it? If so, where do we go from here?
No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space. And none will be so difficult or expensive to accomplish.
We will meet, probably this year. Men are already walking on a simulated surface of the moon. But with all we need to do on Earth, will a trip to the moon have been worth it? Dr. Athelstan Spillhouse, President-elect of the American Association for the Advancement of Science and head of Philadelphia's Franklin Institute.
I think that we have to review our priorities on our expenditures of money and see if it isn't more important to spend our money to bring human living in humane surroundings and human values to the people who are on Earth before we go overboard on programs out in space. And I think that this can be as great an exciting experiment to try to abolish the misery of our poor, and particularly the blacks, as exploring space. But I would not want us ever to get to the point where we spent everything on the immediate problems and didn't look to the future, not only in space, but in basic research and in the things that are also necessary for people.
Dr. Wilmot Hess, Director of NASA's Science and Applications Division.
The question of what do you do after you have gone to the moon, the first thing I would say is you go to the moon a second time. You are given the opportunity of understanding another major body in the solar system, and in doing that, probably to understand something about the origin of the solar system and something about other objects in the solar system. I don't know how to put a price tag on that, and I'm sure to the people who are strongly interested in this area, they would say that the program was worth that.
Dr. Bruce Murray, chairman of the Department of Planetary Sciences at the California Institute of Technology.
That part's all for free. It's very tough to say where should we go after the moon. A lot of people are worried about this. Some would like to use these big boosters and do very big things, like send a man to Mars. I think a more sober view, as well as a more economic one, would say that man's role in space after Apollo should be on his own merits. If he's that important to the operation of a complicated instrument system, then fine, we'll pay the penalty in weight and in survivable equipment for it. If, on the other hand, he can be really just nothing but a passenger, or maybe even a basket case, we don't want him. The most exciting missions of the 70s and 80s, I think, the ones I think that the history books will be writing about, are the first close-up looks at the more distant planets. We've had a close-up look at Mars, enormously surprising discovery of the fact that it looks like the moon rather than the Earth, and that all our previous ideas were wrong, were filled with misconception. I think the same thing will happen if we get a close-up look at Mercury. A close-up look at Jupiter, which is such an enormous thing, can't help but be exciting. The satellites of Jupiter, which are as big as the moon itself, are totally unknown. And finally, by using the massive gravitational attraction of Jupiter itself as a slingshot, we can fire ourselves out into the very depths of the solar system, to Saturn, Uranus, and Neptune, and look at the whole totally unexplored area in the solar system for the first time. These are the historic milestone missions, I think, of the 70s and perhaps the 80s.
Extending its beauty beyond the horizons, space, in all of its strangeness, stands as a challenge of our time, a test of our boldness and also of our wisdom and responsibilities to one another here on Earth. In the final analysis, the question is not, will man extend his view from space? The question is simply one of priorities, of timing. Not will we, but when will we? For all of man's staggering achievement, the stars today are but little closer to his grasp. We will reach the moon, perhaps the planets. After his incredible voyage around the moon, Colonel Borman, addressing a joint session of Congress, put it this way.
Exploration really is the essence of the human spirit. And to pause, to falter, to turn our back on the quest for knowledge is to perish. And I hope that we never forget that.
This has been a presentation of ABC News.